Now you all know Massimo. He's one of our organizers, but he's also a research data scientist, and he's the founder of Complex Science Consulting and member of the organizing committee from not now only, but many years in a row. So he will talk to us about cognitive network science reconstructs how students and experts perceive STEM disciplines. Thank you, Massimo.
Thank you, Evelyn. You all see my screen, right? So I can talk and we all see the same things. Okay, good. So this talk, I would like to start it by introducing you to Mike. Mike is a high school student. He studies some STEM subjects and he's all smiling over the books he's studying in the library. And Mike says that actually he never understood science and he's proud of it. There is a concerning growing body of evidence in the scientific literature telling us that not only students do not like science, STEM stands for science, technology, engineering, and mathematics disciplines. Not only they don't like them, but they're actually happy that they don't like them. They are proud that they don't like them. This negative attitude of closure is quite concerning, and we need to further investigate this. But how can we do this? How can we get inside people's minds, in particular students' minds, and try to understand how do they think about STEM subjects? We need the right access key. And we might try to attempt and do this by accessing the so-called mental lexicon, which is a really fascinating system. Decades of research in psychology and psycholinguistics told us that this structure is a sort of idealized cognitive system that arises from the circuitries in the human brain, but it acts as a knowledge repository that dynamically stores, processes, and produces knowledge in terms of linguistic content. The problem with this is that this structure is different from the human brain. The human brain, we can bring it to the lab, we can tinker with it, we can see which parts of regions of the human brain are connected with each other, or we might bring alive people in the lab and test which parts of the brain are firing when people do some different tasks. We cannot do so with the mental lexicon, which is purely ideal. In order to really assess and investigate how knowledge is structured and perceived in this mental lexicon, we need to access some representations of the lexicon. And in this case, complex networks can be extremely powerful assets. The idea also reminiscently of the previous talks that we had before, the idea is that we build a representation of knowledge in the mental lexicon coming from specific groups of people. For instance, a population of students and a control population of researchers. We perform the same cognitive experiment with them. We reconstruct two different network representations of knowledge of the mental lexica of these people. This is what we did in a collaboration with several researchers. Also, we have here with us Alexandra Alorich and Cynthia Su, who just left. In our paper in 2019, what we tried was suggesting a different way of representing this lexicon through forma mentis networks. Forma mentis in Latin stands for mindset. And these networks represent concepts as nodes interconnected by memory recall links. And they are also weighted, these nodes are also weighted according to emotional perceptions. So that in here, for instance, in blue, I'm plotting words that are positively perceived by a certain population. So that these forma mentis networks combine conceptual associations, associative knowledge, and emotional perceptions. And the type of associative knowledge that we investigate here is called free associations. They are very simple memory recall patterns. Let's do a simple example. You can write it in the chat if you want. What is the first word that comes to your mind when you read complex? Let's see if, when you read complex, what is the first word without thinking of anything? What is the first word that comes to your mind? Okay, we have some answers. Let's see, networks, data, perfect. We did something similar with the students. Let me close that. Very good. We did something similar with the students. We did it with the 159 students. I will talk about it later. But you see, this is a very simple cognitive experiment. For instance, in here, when I read complex, I think of system, mystery, and emergent. Imagine doing this for not only for one word, but for a list of words. Then you get also the associates to these words. You can build a network out of these associations. And in psycholinguistics, pre-associations have been extremely powerful in predicting and understanding a variety of psychological and cognitive patterns like identification, memory patterns, predicting early word learning, assessing creativity levels in individual, reconstructing writing styles and enable author identification, and even better understand and predict also cognitive decline in clinical populations. So they are quite useful tools for the investigation, and we can use them also for educational research. These conceptual associations, we use them in synergy with the emotional perceptions. The idea is very simple. Very much like atoms, like in physics, we know that an atom can have a certain number of electrons. Well, also words have this number that is called valence, that it's how pleasant a given concept is perceived. We asked for people to rate concepts based on a Likert scale, and we did some statistical testing, and we identified which concepts were positive, negative, or neutral in the people's minds. And we then introduced this idea, okay, so I can say that university was perceived as a positive concept in here, but in the network, university was associated with a certain other amount of words. So we introduced this idea of emotional aura. What is the most common valence label in the neighborhood of a certain concept? So the idea is that what is the connotation of memory recall patterns that people thought of when thinking of a certain concept. So this emotional aura, I know it might sound a little bit funny, but in psychology, aura means connotation. It has been used as a synonym of linguistic connotation. So when we think about an emotional aura, we think about the connotations that people attributed to concepts in addition to just the concept itself. And we did this reconstruction, this cognitive experiment with 159 high school students across 3 different schools in southern Italy and 59 early stage researchers in STEM, mainly PhD students and postdocs, which I will call professionals because they got a degree and they were also actively working in research and STEM. A preliminary finding was that on this complex network of associations and auras, we found out by cross-validating the data with another data set, we found out that negative words surrounded by negative concepts elicited stronger patterns of anxiety, a negative feeling of distress and negativity about concepts. This will be useful in the following. Well, now we come to the fun part of the talk. It's time to check the usual suspects and see what the data says about how they are perceived in the students and the experts' mindsets by using formamentist networks. We start from mathematics, which in the professional's mindset was a positive concept associated mostly with other neutral and positive concepts. What do you think should be the case for students? 1, 2, 3, let's think about this. And mathematics was perceived as a negative concept surrounded mostly by other negative or neutral concepts. So mathematics was with a connotation, with a negative connotation, with a negative emotional aura. What about physics? In physics, in researchers, in professionals, in experts, physics is tightly connected with science, model theory, and other mathematical jargon that identifies the idea that physics is an inquisition, like an inquiry of the natural world. In students, that this was not the case. In students, physics was a negative concept surrounded mostly by neutral or negative concepts, except for a cluster of positive words related to labs, to experiments, lab experiments. What about science? Of course, in PhD, well, luckily for us, in PhD students and postdocs, science was a positive concept, strongly surrounded by positive concepts. We expect also for students to provide a negative feeling, a negative aura. No, this is not what we found. we actually found that students thought of science as a positive concept, surrounded mostly by other positive concepts, except for two outliers, which were maths and physics. And this is quite concerning. How come there is this dissonant perception that science is a positive concept, a positive vibe, as long as we don't talk about maths and physics, which are considered as negative concepts? I would like to underline that the same methodology was applied to these two different populations. So it's not like the methodology is biased towards a certain positivity or polarity. This is actually representative of differences that are present between these two populations. And we need to think a little bit more about why. The main advantage of these formamentist networks is that they enable access to the semantic content of knowledge. So it's not much like machine learning. In machine learning, we can say whether something was against or in favor of a given topic. In this case, instead, we can really access the different content that people associated with this jargon. And we noticed that in students, mathematics was mostly related with mnemonic tools for doing calculations. And that was it. Whereas in researchers, there were stronger links between mathematics and physics as a way to inquire the natural world and also as a way to discover the surrounding complexity of the real world. Another thing is that mathematics and physics were perceived as having a negative emotional aura. And we knew that this negative emotional aura corresponding to a feeling of anxiety. So that our study is also a confirmation of other investigations telling us that there is this concerning phenomenon in student populations about math and physics anxiety. When students think in general terms of mathematics or physics, they start getting really anxious about it, about doing maths and physics or even thinking about them. And this may be also a reason behind the negative attitudes that we talked about in the beginning. There is also another thing in that, especially in physics, this is more concerning. Physics, more or less, we know that it is more related to the investigation of the real world. And it's also an adventurous, creative research experience. That is also quite abstract, but it can mediate an artistic adventure. It can be a fun adventure to investigate science. This was mostly absent in the students' mindsets, reflecting a dry perception of physics as something that just relates to calculations. Again, the positive cluster was when students applied physics in the idea of a lab experiment, lab setting. And then in subsequent works, I further investigated and I used this dataset for reconstructing how students perceived the place where the learning happens. And interestingly enough, for researchers, school was a positive concept surrounded by other positive concepts. In students, this was a much more mixed perception. In students, the negativity concentrated around the concept of the classroom and around other concepts like stress and exams. Also, exam anxiety might be another issue, another source for the negative attitude that we see, and that also might reverberate or like diffuse towards the school concept. Unfortunately, we don't have the power to say this here, but this calls for future research in this direction. And then in another collaboration with Anastasia, with Catherine and Stephen, we tried to investigate whether or not this negative attitude was also related to something that was missing, a gap in the computational thinking mindset that could be present in researchers and could be missing in students. And our investigation confirmed this. For instance, the way that students semantically frame model through this experiment is very much related to photography, fashion, and very weakly related to experiments and science. Whereas in researchers, there is a much more tightly interconnection between model, research, science, and simulations, which were extremely, extremely negatively perceived by students, mostly in relations to exams and faking things. And in another small paper that I published in the recently launched International Journal of Complexity in Education, was the identification of the perceptions that students and researchers had about complex systems. In the students' mindset, complexity was related mostly to difficulty, as it is in common language. In computer scientists and in the experts' mindset, instead, complexity was mostly related with the complexity science. So maybe the presence of this gap might be a suggestion for the future to try and change the perceptions that students have of complexity and make them aware about computational thinking and complexity science and network science as concrete ways to improve the mindset that these populations, that these students have. So that the current picture is the one of a fragmented STEM perception, where science is seen as an abstract concept and the building blocks of science, the more quantitative disciplines like maths and physics, are dramatically seen as negative and anxiety eliciting. We should try to take actions and transform this into a virtuous perception of STEM. Likewise, the one that we found quantitatively in the researcher's mindset. And this is important for several reasons, not only because probably people like me or like everybody will be replaced by bots in the future, but mostly because if we want to keep up to date for the job market at the policy level, we definitely need for students to acquire data science and data literacy skills that will make them employable in the future. So even beyond the personal development of being able to process and understand science correctly, there is also definitely like economic and social implications for this concerning phenomenon. And we need to do something to take actions to develop data-informed and data literacy processes. And this is why I also appreciate so much the efforts of NetSciEd in promoting the network literacy and the data literacy programs. And I think also we need to join forces between researchers, students, and teachers and educational professionals in general in order to really bring these new ways of these new tools from computational thinking and from complexity science and network science in schools and involve them in potential research action plans that would be extremely important. And last but not least, shameful advertisement. If you're interested about the cognitive aspects of knowledge and education, please join us at the Complexity and Cognition Satellite at the next conference on complex systems 2020, which will be online and basically for free. You just need to register at the conference and you can pay a small fee and attend as many satellites as you want. Okay, thank you for your attention.
Thank you very much, Massimo. So I see questions in the chat. I can try to bring them together to tell you. I also have a question, but I will say in the end if it's not covered already. So, for example, I see a comment here from Elena that it would be interesting to compare how the students, I mean, you see too, from low and high math competence, how they perceive math and science. I think you didn't distinguish in this work, right?
No, we didn't. But that would be extremely useful. You know, the problem is that at that time, like I did the analysis when I was still doing my PhD. At that time, I didn't know that there was such a complex bureaucracy for accessing the data, because school grades are like privacy. They are. It's also true that they are. It's also good that they are. They are private data. So it's important to get the authorization from also the school deans and the school institutions in order to get them. It was difficult back then, but now it would be really interesting to see whether better students might have a different perception than let's say less well-performing students.
Okay. Then there is another question. If we know about the career goals of the students, again, we don't know. I think it's also interesting to get this at some point.
Yes, yeah. So I did just an inquiry, and all of the students wanted to pursue a university level study after their degree. All these students were also at the final year of their degrees. So they were at the time where they had most of the knowledge coming from their secondary high school studies. Of course, I didn't know if they wanted to pursue a PhD or pursue further scientific goals. It would be interesting to try and check whether that had an influence.
When you say university degree, you mean in general or in STEM university degree?
In general, in general.
Okay, then there is a question. Wait. No, it's not Does the emotional aura change compare students' networks before and after education?
Yeah, that's a very good question, and I didn't publish this data set, but it looks like it can change. I did a consulting for a Norwegian startup, and before and after a 3 months training, students coming from engineering and nursing, they improved drastically their perceptions of specific concepts about computational thinking. So it might be that this methodology is also sensitive enough to display these changes over time in the mindset. It would be interesting to do this also in a classroom setting, before and after a course.
So the data you said now, they were from whom?
This data about the Norwegian consulting, it's data that I gathered about a small class of 8 individuals. The data that I presented here, it's like about 220 individuals.
So my question is related with all this. First, the researchers, the professionals were Italians or were around the globe? They were Italian?
The professionals were around the world, and they were interviewed according to the WWCS, a winter workshop on complexity science. They were from international venues, so they had different careers. They had also different expertises. They were not only physicists, but they were working towards like the completion of a PhD or a postdoc.
My question is, so I was thinking it would be maybe more direct to make this thought if they were Italians, but I was thinking that like those people who become professionals at some point in the past, they were students themselves. So we could expect that they had a similar approach to science and math, more if they were Italians, but maybe in general, if we think that the educational systems have similarities across the countries. So I was wondering if you had data from them, or I wanted to suggest that maybe it would be interesting to get such data from interviews or from them to see what they were thinking back then, so that we understand what made them change their.
I agree. This would be a very nice idea. I think it's a bit difficult to do because we get cognitive biases. We tend to unfortunately forget negative emotions over time, or we tend to catalyze them towards specific events. So it's a bit difficult to ask them, how did you, but it would be interesting to do that, to do this for professors and see what they think about specific aspects of data science and STEM. It might be that also some professors about mathematics, they don't like very much chemistry or whatever, but it would be definitely interesting to do this kind of investigation also for professors who really advance their career, absolutely.
Okay. I don't know if I missed the question. I think we can continue, or I don't know if someone wants to ask something else right now.
I had a very simple question for Massimo, the technical one. I mean, whether this aura is a node or a link property.
Yeah, sorry. This is a network neighborhood property. Like I can share the screen again. And the idea is that the node possesses a negative aura. So the property is computed from the neighborhood, like in here. I check complex, I check the neighbors of complex, and I count how many of them they have a positive or a neutral or a negative aura. And then I attribute this feature to the node, to complex.
Okay. Okay. There's a sort of co-occurrence of this aura.
Exactly. It merges like this is both dependent on the network and on the emotional labels of the associates. So it combines both the network structure and the emotional data.
Great work, Massimo.
Thank you.
Congrats.
Okay, thank you very much, Massimo.